Hi class, today we are looking at some properties of exponents and how exponents work. Before we get going on this, there's a few things we need to understand and understand the difference between. So with almost all of our rules, multiplication is happening, okay? So everything is all multiplication. If there's addition or subtraction happening between our variables, if there's addition or subtraction happening between our variables, then something different is going to happen. So you have to understand that 3 times 3 is 9. But if we have 3 plus 3, that's going to give us 6. Again, I'm not insulting your intelligence here. You have to understand the difference between those. Because when we start to use variables, that gives us x squared, and if we have x plus x, that gives us 2x. Something completely different here. Okay, let's just use one more example. 4 times 4, that's 16, but if we add 4 and 4, we get 8. Okay, so please understand that as we move forward. You're going to be hearing the words simplify and expand a lot. So when we're looking at exponents, first of all, we have the base and we have the exponent. This is simplified form. We have one base and one exponent. That's simplified form. Expanded form is the meaning of what 3 to the 5th is, which means 3 times 3 times 3 times 3 times 3. 3 times itself 5 times. Okay, so again, we've got the base and the exponent. Expanded form, simplified. I like to think of simplified form as almost condensed. Everything's compact as much as we can, okay? Usually with our base, each base only appears once, and we also don't like to have negative exponents. And we're going to talk about that a little bit. The only time we use negative exponents is really in scientific notation. Any other time, if we have a negative exponent, we kick it to the denominator and move on. Okay, so here, let's look at some of our rules and how they apply to numbers. Think about if we have 2 squared times 2 to the 3rd. Think about what 2 squared means. In expanded form, it is 2 times 2, and then 2 to the 3rd in expanded form is 2 times 2 times 2. So if we multiply those all together, what do we get? Well, if we sit and punch it into our calculator, we end up getting 32. But let's think about this in a different way. 2 squared times 2 to the 3rd. What is 2 squared? That is 2 times 2, which is 4. And 2 to the 3rd is 2 times 2 times 2, which is 8. 4 times 8, what is that? That is 32 as well. Okay, so everything still means the same thing. They're just a little bit different views. Well, we can also rewrite this. How many 2's do we have? We have 5 2's. So 2 to the 5th, if you were to punch that into your calculator, the same thing. We still get 32. So think about how we can apply our rules. Think about what's happening here. Try another example. Now we can look at some division. Let's say we have 2 to the 3rd again. There's that 2 to the 3rd over 2 squared. Okay. We just have a fraction, and I want to make sure you understand. Let's always use that fraction bar and eliminate that little division symbol with the dots from our vocabulary now. We want to work with division as basically a fraction. So we've got 2 to the third over 2 squared. Let's write that out in expanded form and think about what it means. Okay. What happens if we take 2 and divide it by 2? 2 divided by 2 is 1. So if we take 1, 2 in the numerator and the denominator, those can be divided to make 1. And if we do that with another pair of 2's, we don't have any 2's left in the denominator, but we have 1, 2 in the numerator. That's 2 to the first, or 2. Let's think about this another way. 2 to the third is 8. 2 times 2 times 2. 2 squared is 4. What is 8 divided by 4? Still 2. Are you starting to see a general rule? Two to the third minus 2 is 2 to the first. Something to think about. Now, what happens if we take something and divide it by itself? You had 9, and you divided it by 9. What do you get? You get 1, right? Think about the rule we just looked at. Think about expanded form and what ends up happening. How many 2's are left? How many 2's are left? Ooh, we're coming back to that 0 power again. And this is kind of the reason why. This is the proof of why we can say anything to the 0 power is 1. Because that would be like saying something divided by itself. That's always going to be 1. Think about this when you're looking at zeros. Okay? Another number application is going to be a power to a power. Okay? Think about the meaning again. Think about the meaning. We want 3 of what's in parentheses here and what is directly in front of it. Okay? So how many 2's do we have? We have 6 2's. We could also, 2 squared is 4, right? What does that mean? That means 4 to the third, which is 4 times 4 times 4. Again, if you punch that into your calculator, we get 64. So we're looking at the same values here. We're just trying to show you different ways to express those values. We could also simplify this to 2 to the 2 times 3. Now, what if I had 2 numbers in those parentheses? What do you think we would do there? Two times 5 to the third. We could multiply the 2 times the 5, and what do we get? We get 10 to the third. What does this mean? 10 times 10 times 10. Over here, 2 to the 5 times 2 to the 5 times 2 to the 5. How many 2's do we have? How many 5's do we have? punch this into your calculator. 2 to the third is 8. 5 to the third is 125. 10 to the third is 1,000. 8 times 125. There's just a little math magic for you. Hopefully this will help bring all of those inquiries that we've been working on in class, or that you will be working on in class. Hopefully they'll start to bring things together a little bit, and we can apply them to variables and other numbers. Thanks. Have a great day.